Okay, this is the last lesson in Chapter 4. This is Lesson 3, and we're going to finish up with oxidation reduction stoichiometry, redox stoichiometry, and we're going to revisit reaction prediction, which we did some in the last lesson. Some of what we're going to do today is going to be a review of Regents Chem, and then some of it will be new. The first part should be a review. Rules regarding oxidation numbers. So atoms have oxidation states of 0. So that means if I have an atom by itself, for example, anything that is Brinkelhoff. So if I have Br2, it gets assigned an oxidation state of 0. It's considered to be in the free state. If I just had calcium, solid, okay, it's by itself, free state, it gets assigned a 0. So all Brinkelhoff and any atoms in their free state get an oxidation charge of 0. Ions keep their charges. So for example, if the problem said Na+, then it's a +1 charge on the ion. If it said CO3 2-, then that's the ion, so we use the charge on the ion. Oxygen is always going to be -2 unless it forms a peroxide. This is an exception to the rule, in which case it will be -1. Fluorine is -1. Hydrogen is always +1 unless it forms a metal hydride. And an example of a metal hydride would be LiH. This is lithium hydride. Your lithium is +1, so your hydrogen has to be another one. Another one might be MgH2, magnesium hydride. Magnesium's +2, therefore your H is -1. So hydrogen's always +1 unless it forms a metal hydride. Remember that the sum of the oxidation states must equal the charge of the substance. If it's a compound, it's going to equal 0. If it's an ion, then it's going to equal the charge on the ion. So let's do a couple of practice ones. I'm going to start with one of our exceptions. Let's start with H2O2, which is your hydrogen peroxide. Your H is going to be +1. +1 times 2 is +2. Therefore, in order for this compound to have a net charge of 0, because it is a compound, then oxygen must be -2, and there's 2 of them, so each one is -1. There's your exception to the rule where oxygen is -1. Here's an acid, HNO3. So we know that oxygen is always -2 unless it forms a peroxide. That gives us a net -6. H is always +1 unless it forms a metal hydride. That's not what we're dealing with here. Therefore, in order for this to equal 0, my nitrogen must be +5. We did this in Regents Chem. This is just a review of that. Some of you haven't done it in a while. CO2, oxygen is -2. That's a net -4. Carbon must be +4 in order for this to be 0. Now, when you're doing this in an equation, I don't need to see all the math here on the bottom. You know, you can do the math in your head. I'm just showing you how we're arriving at these charges. So don't feel compelled that you have to write this down, because I'm not looking at this bottom line. I'm only going to be looking up here to make sure that your oxidation states are correct. Sodium dichromate. Here's a nice one. Oxygen's -2. This is -14. Na can only be +1. There's 2. That gives us a net +2. In order for this to be equal to 0, chromium must be total of +12, but there's 2 of them, so each one is +6. And lastly, let's throw an ion in here, NO3 -1. So remember, when I have an ion, the sum of the charges, oxidation states, equals the charge of the substance. So now this overall ion has to equal a net -1. I'll put a down arrow here. So it has to equal a net -1. Okay, so oxygen is -2. That gives me a -6. In order for this to equal a -1, nitrogen has to be +5. And now it equals the charge on the ion. Let's review some definitions. Oxidation, remember the saying, Leo says ger. So right from there, oxidation, loss of electrons is oxidation, and therefore a gain of electrons is reduction. Remember that the oxidizing agent is, and the reducing agents are opposite. So the oxidizing agent is the thing. It's really species that is reduced. And reducing agent is the thing or species that is oxidized. Okay, so that's a general review of Regents Chem. Let's see if we can identify what's going on in these problems. So we're going to identify what's oxidized, what is reduced, the oxidizing agent or the OA, and the reducing agent, just so we can review those terms. First thing we want to do is find anything that's in the free state, so I know right off the bat that oxygen is going to be 0. S is -2, which means that Pb is +2 in this case because they combined it a 1-to-1. Same thing here. And this is -2, which gives me a net -4, so the sulfur must be +4. So remember, when you have Leo, loss of electrons is oxidation. When you lose electrons, then it becomes more positive. So whatever's being oxidized, so 0 to -2 is not becoming more positive. However, sulfur going from -2 to +4 is becoming more positive. So the S is oxidized. It's going from S -2 to S +4. And when we have a gain of electrons, you're gaining electrons, you're becoming more negative. It's an easy way to think about it. So we saw that oxygen was going from 0 to -2. Therefore, oxygen is reduced. So O2 is reduced because it's going from O2 0 to O -2. Okay. So what that means is if the oxygen is being reduced, then it's really my oxidizing agent, because we said the thing that's the oxidizing agent is really the thing that's reduced, and the reducing agent is really the thing that is oxidized, which would mean that PbS, this is the species, is the reducing agent. Okay, let's take a look at another one. So I see Cl2 by itself, it's going to get a 0. Nothing else is by itself. Here I have an ion. So my O is -2, my H is +1, which is going to give me a net -1. Here my O is -2, my Cl is +1, which is going to give me a net -1. My Cl is -1, I got to use the charge on the ion. And here oxygen is -2, and H is +1. So right away I see chlorine, Cl2, is going from 0 to +1, but Cl2 also goes from 0 to -1. So here, chlorine is both oxidized and reduced. Oxygen is staying the same, hydrogen is staying the same. And this is possible in a reaction. Okay, now here's where things are going to become new. Balancing redox reactions. Balancing redox reactions is going to be different than balancing a regular reaction. And the rules change depending on whether the solution is an acidic solution or a basic solution. So we're first going to solve and go through the rules in an acidic solution, and then we're going to go through the rules in a basic solution. This is not hard. You have to memorize the slight difference in the rule. It's procedural in nature, and you just need to make sure that you're doing your math correctly. It's just simple math, but there's a lot of math, and then there's balancing, canceling out. So you have to really be meticulous in your work, is I guess a good word. So the first thing that we're going to do is write reactions as half reactions, one for oxidation, one for reduction. Then we're going to balance all elements except H and O. Then we're going to balance H with H+, O with water. We're going to balance the charge on the electrons, and then multiply reactions by factors such that electrons cancel, and then add them up to get a final reaction. And it sounds more complicated than what it really is, so I'm going to go through the steps one by one. The first thing I'm going to do is assign oxidation numbers to each element. So -8 here, but remember we have this -1 charge, so this is going to be a +7. Fe is going to be +2. I'm going to just circle that, remind us that's the charge. This is going to be +3. This is going to be +2. And they're telling you, and it's an acidic solution. So you've got Mn going from +7 to +2. So we're going to write that down. MnO4 minus going to Mn +2. Okay. So the first thing that we want to do is balance all elements except H and O. Well, we have one Mn, one Mn. So we've done that. Balance H with H+. There is no H here. Balance O with water. So I'm going to balance, these two actually should be reversed. Sorry about that. Balance O with water. Reverse those rules. So we have 4 oxygens, so I'm going to add 4 H2O. So now I have 4 oxygens, 4 oxygens. But in doing that, I now have 8 H+. So now I'm going to add 8 H+ to this side. That's where we're balancing the H with H+. Now we have to look at the charges. So on this side I have a net +2 because this is a compound. Over here I've got a net -1 and a +8. That's going to give me a net +7. If I have a +7 on the left and a +5 on the right, I'm going to add 5 electrons to this side because they're negative. So that gives me a net of +2 on both sides. Now let's do Fe. We're done with that one. We're going from Fe 2+ to Fe 3+. Mass is balanced. I have nothing to do but balance charge. So I'm going to add 1 electron to the right-hand side. Plus 3 and negative 1 is plus 2, gives me a plus 2. Now my electrons can't cancel because I have 1 and 5. This is the next step. Multiply reactions by factors that cancel E. I'm going to multiply this whole reaction by 5. So that's going to give me, I'm going to write that, I'll rewrite it down here in blue. It's going to give me 5Fe, 2 plus, going to 5Fe, 3 plus 5 electrons. Let's cancel what we can cancel. Electrons cancel. Nothing else can cancel out. I have no other like terms. So then I can just write my final reaction. So I have 8H plus 5 Fe2 plus MnO4 minus yields 5 Fe3 plus Mn plus 2 plus 4 H2O. Doesn't matter what order I write things in, as long as what's on the left stays on the left and what's on the right stays on the right. So that's acidic. We're going to practice 2 more in acidic. So here I've got a 0, I've got a -1, +1, -2, +1, +6, -2, but I need a net -2 charge, so this is going to be +4. All right, so let's look at what's being oxidized, what's being reduced. Chlorine. So we've got NaCl going to Cl2. So the first thing I have to do is add balance mass. I have 1 Cl here, 2 Cl's here. So the first thing I'm going to do is put a 2 in front of this NaCl. Now my Cl's are balanced, but I have to balance my Na. So I'm going to need to add 2 Na plus to this side. I'm just adding the atoms. Okay, so they're ions. Now what I'm going to do is balance charge, because there's no H, there's no O's. My masses are all balanced. I got a balanced charge. So I have a net +2 on this side. This is 0. So I'm going to add 2 electrons to the right. So now this is 0, this is 0. For my other reaction, I've got K2SO4 going to SO3 2 minus. So I'm going to balance everything that's not H or O first. So that means I've got 2 K's here. I have to add 2 K plus to this side. Now I can balance, well, my S's are balanced, oxygens. I have 4 oxygens here, 1 oxygen, 3 oxygens here. So I need to add 1 water to balance out my O's. 3 and 1 is 4 O's, 4 O's. But now I have 2 H's. So I have to add 2H plus to the left to balance H plus. So now all my atoms are balanced. I look at charge. I have a net +2 on the left, and I have 2 times +1 is a +2. A +2 and a -2 is 0. So I have a 0 versus a +2, so I'm going to add 2 electrons to the left. Well, my electrons are balanced, which makes this nice and easy. I can cancel electrons, and nothing else to balance or cross out, reduce. I have to bring everything down. So I've got 2H plus K2SO4 plus 2 NaCl yields Cl2 plus 2 Na plus SO3 2 minus 2K plus and H2O. Let's do one more and then we'll move on to basic. So here I have a plus charge on the H, a plus 2 on the Fe. I've got a negative 2 here, negative 14, but this is a negative 2 charge, so this is going to be plus 6, negative 2, plus 1, plus 3, plus 3. So let's look at what's going on here. I've got Cr2O7 going to Cr3 plus. I have 2 Crs here, so I need 2 Crs here. I have 7 oxygen here, so I have to add 7 waters, which is going to give me a net of 14 H plus on the left. So I have 2 times 3, which is a net plus 6, versus a net of 14 plus, which means I need to add 6 electrons here, because a negative 6 and a positive 14 is a net nope, I need 7 electrons. Ah, I saw my mistake. Let me stop. Got carried away. There is a negative 2 charge on this. Okay, so this makes a difference. So a positive 14 and a negative 2 is a net plus 12. Net plus 12, and I have plus 6. So I need a negative 6, because a positive 12 and a negative 6 gives me a net plus 6, which matches what I have on the right. See, I was not being meticulous. Okay, so what else is changing? So this was, when we did this reaction, this was the Cr going from plus 6 to plus 3. So this was our reduction reaction. And now we have to do our oxidation reaction, which is plus 2 Fe going to plus 3. And then I'm just going to add 1 electron here. Now notice we didn't do anything with the H and the H2O because they weren't being oxidized or reduced. Your half reactions are only based on what's oxidized and reduced. I'm going to have to multiply this reaction by 6 to give me 6 Fe plus 2 going to 6 Fe plus 3 electrons. And then when I cancel, these cancel, nothing else cancels. So I have to bring down what's left. So I've got 14H plus 6 Fe plus 2 plus Cr2O7 2 minus going to 6 Fe3 plus 2 Cr and 7 H2O. Okay, so that's it for acidic solutions. Let's move on to basic. Now, everything is going to be the same, except after, and these are reversed again, we do the O and then we add the H plus. After we add H plus, this is the only new step. We're going to balance those H plus with OH on both sides. And that is going to make water. So this step makes water basically. And then we can cancel out any extra waters and OHs if we have enough on both sides to do so. So let's put this into practice. Al is going to be 0. This is going to be plus 7, plus 4. This has got a negative 1 charge here. So my Al My Al is going to be plus 3. Hold on one second. No, that's right. That's right. Al is going to be plus 3. My O is going to be negative 2. My H is going to be plus 1. Okay. All right. So let's see what's oxidized and reduced. Well, we can see Al absolutely is going to be oxidized. We'll handle that first. So we've got Al going to AlOH 4 minus. So the first thing that I'm going to do is my Als are balanced. I have 4 oxygens here. So I need to add 4 waters to the left, which gives me 8 H's. Now, I already have 4 H's here. So if I have 8 H's and 4 here, I'm only adding 4 H+. Here's my new step. I am going to add, let me change colors so you see that, plus 4 OH minus to both sides. This right here, I'm going to circle that because that makes 4 waters. Let's look at my charge. And I circle that because I don't want to include that in the charge. Okay? That's why. This is now neutral, 4 waters. So I have a net negative 4 right here. And I have a net negative 1 here. So that means I need to add 3 electrons. So I have a negative 4 versus a negative 4. Let's look at the other part of this. We've got MnO4 minus going to MnO2. My MNs are balanced. I have 4 oxygens, 2 oxygens. So I'm going to add 2H2O. So my oxygens are balanced, but now I have 4H+. So I'm going to add 4H+ over here, which means that I have to add 4OH minus. I'm going to circle them right away. They make water, plus 4OH minus. Now let me look at my charge. I have a negative 1 and I have a negative 4. So I'm going to add 3 electrons to this side. So that gives me a net negative 4. Let's cancel some stuff out. I can definitely get rid of my electrons right away. I have 4 waters on the left of this reaction, 4 waters on the right of that reaction. I can get rid of that. I have 4 OH minus on the right of this reaction, 4 OH minus on the left. And I have 2 waters on the right of this reaction, which means I can reduce this to 2 waters. So on this one I got rid of a lot of junk. And I've got 2H2O left, plus Al, plus MnO4 minus, yields MnO2 minus, MnO2, sorry, plus AlOH4 minus. And that's that one. Let's do another one for practice here. Cl2 is 0, O is negative 2, K is plus 1, Mn's plus 7, negative 2 plus 4, negative 2 plus 1. That gives me a net negative 1, which I need to have. So I've got Cl2 going to ClO minus. First thing I notice is I have 2 Cl's here. Need to put a 2 here. 2 Cl's. Now I've got 2 oxygen. So I'm going to add 2 water. Now I got to balance my H's, so I'm going to add 4H plus over here, which means that I have to add four OH minus. I'm going to circle them right away. That makes water. It's neutral, plus 4 OH minus. That gives me a negative 4 on the left, and 2 times negative 1, don't forget that distribution here, is a negative 2, So I'm going to add 2 more electrons to the right, so I have a total of -4 on both sides. Now let's look at the KMnO4 going to MnO2. So K is not on the right, so I'm going to add K plus to the right. Then I'm going to look and I see I've got 2 oxygens, 4 oxygens. I'm going to add 2 water to the right, which means that I'm going to add 4H plus to the left, which means I'm going to add 4OH minus to the left. That's neutral, it's water, plus 4OH minus to the right. That gives me a -4, and a +1 is a net -3. So I'm going to have to add 3 electrons to the left to give me a net -3. Well, here's a problem, because this is -2 and this is -3, so I just made a whole lot of work for myself. Because the least common multiple between these two is going to be 6. So this whole reaction has to be multiplied by 3, and this whole reaction has to be multiplied by 2. So I'm going to rewrite those. So that means now I'm going to have 12 OH minus plus 6 H2O plus 3 Cl2 going to 6 ClO minus plus, this is 4 waters times 3 is 12 H2O plus 6 electrons. And my other reaction is going to be 6 electrons plus 4 waters times 2 is 8 waters plus 3 KMnO4 plus, oops, not 3, 2. I looked up at the wrong one. Sorry. This was 3 Cl2. Alright, so backtrack. 4 waters times 2 is 8, and this is going to be 2 KMnO4 going to 2 MnO2 plus 2K plus 2 times 2 is 4 waters plus 2 times 4 is 8 OH minus. Okay, let's see what we can cancel out here. Alright, I'm going to start with water. I've got 6 waters and 8 waters, which is a total of 14 waters. And I've got 12 waters on the right. So I'm going to get rid of the whole 12. I'm going to get rid of this, and I'm going to change this to 2. Because 14 versus 12 leaves me a net of 2 waters. However, I now see I still have 4 waters over here, so I can get rid of this completely and make this 2. Okay, I have 8 OHs, 12 OHs, so I'm going to make this 4 OHs. And I have 6 electrons, 6 electrons. I don't think I can do anything else. So I've got 4, so now we're going to just, oops, sum it up. 4 OH minus plus 3 Cl2 plus 2 KMnO4 yields 6 ClO minus plus 2 MnO2 plus 2K plus 2 H2O. This lesson is turning into be rather lengthy, so I'm going to make a 3B, which will finish up the redox stoichiometry and revisiting predicting reactions.